Hi guys, so in order to get started today, you need your notes chapter 9. You should see what you see on your screen here. And then we're going to get started. So first things first, I'm going to zoom in here. So first things first, we're going to talk about X and Y intercepts. And you're probably super familiar with these, but we'll just go over them so everybody's on the same page. So the X-intercept is the point where, excuse my handwriting, where the graph crosses the x-axis. Right, crosses the x-axis. Right, so that's my x-intercept. So I know here is my x-axis. So I'm going to look for all the places where it crosses that line. So I'd see that I have a point here, a point here, and a point here. So I would say that the x-intercept is in 3 places. So if I'm going to write this down, my x-intercepts, I'd write down their points. So -3, 0. And that looks like it's about halfway between 0 and -1, so probably -0.5, 0, and 2, 0. Alright, so that is my x-intercept. My y-intercept then is the point where the graph crosses the y-axis. So the graph crosses the y-axis. So my y-axis is up and down here. That's a terrible line. But I want to look for where the graph crosses it, and that would be right here. Right, so right there. And I could go ahead and say, okay, my y-intercept is where it crosses the y-axis. It's going to be at like, it's 0 because I'm not moving anywhere left and right, but then like 1.5. So fairly simple. We're just thinking about where our x and y axis is, and then seeing where it crosses the line. So next we're going to talk about increasing and decreasing here. So increasing and decreasing, a function is increasing on an interval if the y value increases as the x value increases. So basically what that means is the function is increasing if it's going up, if you're moving from a left to right action. So if I'm looking at this graph here, I see that I'm going down, right? So I see that I'm going down up until this point, and that would not be increasing, that would be decreasing. But starting here and moving all the way up here, right, that would be increasing. And we always mark that as like an interval, just like we were doing domain and range yesterday. So we tell it the y that it the x that it starts, and the x that it stops. So I could say that this is increasing from -2 on the x-axis. I'd probably put, it actually is not included there because at that individual point it's just constant. So it's increasing at -2, from -2 all the way to the x value of 1. Notice I'm looking at my x value here, not my y. Right? So that would be my increasing anywhere that it is going up. So from there I'm going to look for my decreasing. Right? So I'll put that in blue here. A decreasing is any time that the y value is decreasing as the x value increases. So this basically just means anytime that we're going down, right, as we move from left to right. So if I'm looking at my function here, I might say, okay, I'm going down as I head down this way, right? So that would definitely be decreasing, right? So I'm decreasing here. I'm decreasing from over here at negative infinity, right? It's going out this way as far as possible. So I know that it's decreasing, and then it's coming in, coming in, coming in. I could say starting at negative infinity, still measuring on the x-axis, all the way to -2, which is where it starts increasing again. You could also just have written this as x is less than -2 if you are someone who appreciates doing it that way. This is not the only place where we decrease. We also decrease on this side of the graph. So we know that we start decreasing again back at, we would write that as 1 is less than x is less than positive infinity, because we are headed in that positive infinity direction. So we have increasing and decreasing. If at any point our graph was flat, we would have what we call constant. And we have constant there. You have it on your paper. I'm not sure I have it on mine. Let's see. I don't have it on mine. But constant would just be anywhere where the graph is flat. The graph is flat. You can go ahead and put that on your paper, which should be right under here. All right, so we have our X-intercept, Y-intercept, our increasing and decreasing intervals. And then we're going to talk about relative maximum and minimums. So the relative maximum is the y value of the highest point in a particular region of a graph. All right, so we're looking for the highest point. It might not be the highest point overall, but it is the highest point in a particular region. So in this case, I might say that this is a relative maximum. So relative to the points around it, this is the highest point that we see. And so we would say that the y value here is 3, right? So the relative maximum is 3. The relative minimum then, of course, is the y value of the lowest point. Right, so the y value of the lowest point, again, in a region, right? Not necessarily the lowest point overall, right? As we see in this graph, we see this is the lowest point in this region. However, there are other points that are lower over here. But we would say relative to the other points, this is our relative minimum, the lowest point around it. Right? So we would say our relative minimum would be -3. Right? So we have relative maximum, relative minimum. And then finally, our last area here, I'll go ahead and use, I've used all my colors, so black. Here I would have my X-intercepts, my zeros, my roots, and solutions are all names that describe the X value of a graph whose corresponding y value is 0. So all this really means is we're talking about the places where the graph hits the x-axis, right? So very much, again, we're talking about the same x-intercepts that we were talking about before, but we want to be really careful that they have 4 different names. So we call them zeros sometimes, we call them roots sometimes, we call them solutions sometimes, and we call them x-intercepts. We often see them written like this, x equals, and then they tell us what those numbers are. So this one would be -3. We have this one here, which would be -0.5. And then we have this one here, which would be 2. So we would see that we would say that we have 3 zeros, or we could say that we have 3 roots, or we could say that we have 3 solutions, or we could say that we have 3 X-intercepts. All of those things mean the exact same thing, we just have another name for them. So that's it. You're going to jump on to, well, you can feel free to jump on to your assignment for today. I also am going to look at the first assignment question, just in case there are any confusions, right? So feel free to jump off at this point or keep listening. So for this problem, it says, for each graph, state the x and y intercepts if they exist, the interval where it's increasing, decreasing, or constant, and if it has a minimum or a maximum. We're going to use interval notation. We also see that this one asks us for our roots and solutions, so we'll be sure to do that as well. So remember, I'm going to look for my x-intercepts, or I'm sorry, my y-intercepts, anywhere that it crosses the y-axis. That will be right here. It looks like that's right about the number 3. I might say 3.1, right? You might say 3 if you're being less specific. For increasing, decreasing, and constant, I'm going to have to do a few. So for increasing, I see that I have this one here. I see that I'm increasing here, and I see that I'm increasing here, anywhere that I'm going up. So for increasing, I would say that I'm increasing from -10 all the way to, what is that number, -7. So I'd say -10 is less than x, all right, less than or equal to x, less than or equal to -7. I'm increasing here from -6 to -2, so I'd say -6 is less than or equal to -2. And then finally I would look at this one, which is a 7, all the way up to here, which is a 12. So I'd say, okay, we're also increasing from 7 to 12. And the reason that I'm putting the equal sign under there is because each of these are closed circles. We want to put we want to leave it without the equal sign when we see an open circle like that. So anything that means not included. So those are my increasing intervals. And then I'm going to go ahead and do my decreasing one. So anywhere that's going down. So I see that from here to here. That's a terrible line. From here to here. And from here to here. So I see only 2 there. So I'd say, okay, it's decreasing from, let's see, -13 on the x to -10. -10. And then also decreasing from -2 on the x-axis to 5. Right, and then constant would be anywhere that is flat, and I don't see any flat pieces here, so I might just make a note, there are no constant, slopes. There's no constant slopes. I'm going to think about my minimums and my maximums. So if I'm looking at this, my minimum is my lowest possible value. So I'd say, okay, my lowest possible value is here. And remember, it's the y value. So I'm going to say, okay, the minimum is 1. There's no other place that's low. We could potentially call this a relative minimum if you are interested in doing that. We could say this is a relative minimum. We could potentially say this is, but it's pretty close to this guy, so it's probably not a relative minimum. So our minimum is just at the number 1 to be really specific. And then our maximum is our highest possible point. And our highest possible point we see is here. It goes over at, looks like 8. So our maximum would be at 8. We could also again say this would be a relative minimum or maximum if you were interested in marking that on your graph as well. For this one, we're looking for our roots or solutions. Remember, that's anywhere that crosses the x-axis. We don't see any here, and so I'd go ahead and write the word none. You're going to repeat this over the course of the next few problems. If you have any questions, shoot me an email or text message. I will be around. Thanks, guys.